Welcome to Edexcel Maths, and today we're going to look at Chapter 3. First of all, we're going to look at linear simultaneous equations, and there are two approaches to solving these kind of equations. The first one is elimination, and the second one is substitution. Let's look at an example here. We have to solve the simultaneous equations 2x plus 3y equals to 8 and 3x minus y equals to 23. First, we need to multiply the second equation by both sides by 3, so we get the new equation 9x minus 3y equals to 69. Then we will have to add the first equation with the third equation, and we get that 11x equals to 77 and that x equals to 7. Then we have to substitute the value of x, which is 7, into the original equation. Then we get that y equals to minus 2. And now we're going to look at the second example, at which we need to use the substitution method. So first of all, we need to rearrange the equation into either x equals to something or y equals to something. In this case, we will rearrange it into y equals to 2x minus 1. And then we'll just have to substitute this into the second equation. So we get 4x plus 2 times 2x minus 1 equals to negative 30. And then we'll just have to solve the equation, and we get that x equals to minus 3.5. Then we'll just have to substitute the value of x into the original equation. And then we'll get that y equals to minus 8. The next thing that we're going to look at is quadratic simultaneous equation, where one equation is linear and the other one is quadratic, and it can have up to 2 pairs of solution, in which you need to substitute the linear equation into the quadratic equation. Let's take a look at this example. We know immediately that we need to use the substitution method. So we will rearrange the first equation into y equals 3 minus x and substitute it into the second equation. Then we get this, and we have to factorize it, and then we get that it equals to 0, so x equals to 2 and x equals to minus 5. Then we just have to substitute the value of x into either x plus y equals to 3 or x squared minus 3y equals to 1, and we get the values of y. Now we're going to look at simultaneous equations on graphs. The first thing you need to know is that the solutions to a pair of simultaneous equations represent the point of intersection of their graphs. By using what we learned in Chapter 2, after substitution, we can use the discriminant to determine the number of points of intersection. b squared minus 4ac, if it's bigger than 0, then it has 2 real solutions, and the graph of linear equation and the graph of quadratic equation intersect twice. And if it's b squared minus 4ac equals to 0, it has 1 real solution and it would intersect once. If b squared minus 4ac is smaller than 0, then it will not intersect, since it has no real solution. And now we're going to look at linear inequalities. You can solve linear inequalities using similar methods to those for solving linear equations, since the only difference is just the equal sign. And the solution of an inequality is the set of all real numbers x that make the inequality true. But you need to remember that if you divide both sides by a negative number, you must change the signs. For example, bigger than will change to smaller than, smaller than will change to bigger than. You may sometimes need to find a set of values for which two inequalities are true together. Number lines can be useful to imagine their set of values. Let's look at an example together. If x is bigger than 0 and x is smaller or equal to 1, then we'll take the parts where they intersect, which is x is bigger than 0 and x is smaller or equal to 1. Sometimes the question might ask you to express your answers in set notation. Then if x is something something and x is something something, then we're trying to find their intersection on the number line. And if x is something something or something something, then we're trying to find their union, which is actually anything covered by these regions. The next thing that you need to know is how to solve a quadratic inequality. You can either do this with a graph or without. I'm going to show you how you do it with a graph first. So first of all, you need to rearrange so that the right-hand side of an inequality is 0. Then solve the corresponding quadratic equation to find the critical values. Then sketch the graph of the quadratic function and use your graph to find the required set of values. And let's look at an example where x squared minus 4x minus 5 is smaller than 0 and we're trying to find the value of x. Then we'll draw a graph, and we know that we're trying to find a value below 0, which is the part that is now red. And we can see that x is bigger than minus 1 and smaller than 5. And if we have to write it in set notation, it is like this. Similarly, if you want to do this question without the graph, then you just need to imagine the shape of it without drawing it. And now we're going to look at how to represent inequalities on graphs. If f of x is smaller than g of x, then you know that the values of x for which the curve y equals to f of x is below the curve y equals to g of x. And if f of x is bigger than g of x, then you know that the values of x for which the curve y equals to f of x is above the curve y equals to g of x. And let's look at an example now. If f of x is bigger than g of x, then it is represented by the yellow section. And we know that x is smaller than 2 and x is bigger than 5. And if f of x is smaller than g of x, then it is represented by the red section, and which is x is bigger than 2 and x is smaller than 5. The last thing that we're going to look at in this chapter is region. So there are some things that you need to know before we look at any examples, which is if y is smaller than f of x, then it represents the point on the coordinate grid below the curve y equals to f of x. And if y is bigger than f of x, then it represents the point on the coordinate grid above the curve y equals to f of x. Let's see what I mean by these on the graph. So y is smaller than f of x can be represented by the purple shaded region on this graph, and y is bigger than f of x can be represented by the blue region. Another thing that you need to know is that if y is bigger than f of x or y is smaller than f of x, then the curve y equals to f of x is not included in the region and is represented by a dotted line. But if y is bigger than or smaller than f of x, then the curve y equals to f of x is included in the region and is represented by a solid line. This is the end for chapter 3. Thanks for watching. See you next time.